In the previous lecture, we had discussed about mobile IP. We had seen several requirements of mobile IP: compatibility, transparency, scalability, and security. We also seen this entities and terminologies of mobile IP and working of mobile IP. We had seen. We had discussed about agent advertisement and agent solicitation. How exactly your mobile node discover the foreign agent by the means of these two uh, mechanism, advertisement and solicitation, where advertisement deals with foreign agent, where it shows its presence inside the network. However, in solicitation, when your advertisement packet doesn't reach you, mobile node itself go inside the network and tell everyone that I am here. If any foreign agent is free, please let me allow to register him. Right? So these are two mechanisms in the thing. After that, these two mechanism, advertisement and solicitation, you got a care of address. It means mobile node gets a care of address, and this care of address needs to be passed to uh, home agent. Therefore, your mobile node needs to register again with your home agent, and how they can do that we had seen in the previous session. Well, after that, we have an important topic known as encapsulation. And I told you about encapsulation, what exactly is. Even still, I'll explain you one more time. So suppose that I'll completely nomenclature here. So your correspondent node has an IP address like maybe 192.168.117.1, and your mobile node, that means your uh, receiver, having an IP address of 168.117. Maybe 10. All right. So here in the case of our example, this is our source, right? And this basic mobile node is a receiver. Um, yeah. So we have a corresponding node and mobile node, which means source and receiver. Um, and your source is interested in communicating with you with this IP address. So he will generate a packet here. So this is a packet. Let's suppose that this is a packet. And this packet has this information, CN and MN, all right? And he will forward this packet to where? It will forward it to something called as uh, permanent IP address of this mobile node. That means this 117.110. So that means it is going to be received by a home agent, right? First of all, it is going to be received by a home agent here in the home network. It will receive. And suppose that this is basically the home network. This is completely home network, right? So this home agent will gonna see that the packet which I received, 117.10, this mobile node. So there are so many mobile nodes. These are all mobile nodes. So this particular mobile node, 117.10, is in my network or not? And let's suppose that this is foreign network here. This is a foreign network, and to handle that foreign network, I have a foreign agent. So he will see that this mobile node 117.10, currently it is not with me. It is actually inside the foreign network. It is not with me right now. It is not in the home network. So he will see that. He will see this. That I cannot forward this packet directly in the home network because my mobile node is not rightly situated here. So what he do, basically he will again uh, form this packet, and the upper layer of this packet he will create a layer known as encapsulation layer. So this is encapsulation layer. So what will happen basically, inside this packet we have an information, this information. So inside the packet we have this information. So this is one thing. Let me box it. This is the information. This is the information. And on the top of that information, he will generate one more information, uh, which is going to be look like this. So now what will happen? The home agent is going to be new source, all right, because he is sending now to the COA of the mobile node, because ultimately foreign this mobile node has sent the COA, that means the temporary IP address of himself to the home agent, so he is having that, right? So he will reformulate it and it will say that 192.168.117.15. So 15 is basically the home agent IP address. Now he will become the source, and just like that. And COA, I mean the mobile node, COA, this is going to be the new IP address 192.168.117. Maybe 1118.2. Okay, so this is basically the COA, right? The temporary IP address in the foreign network. So this information is going to be appended inside the internal information like this here. This, put it over here. And then it is going to be boxed here. Okay, so this complete information, I'm so sorry, I need to say this looks good. Okay, so he will box this information, and this complete box is going to be known as encapsulation. Encapsulation. And there are many types of encapsulation we can do. The basic one is IP to IP basically, but I'm writing here minimal encapsulation because this is in your course. And there is one more something called as a generic routing encapsulation. So I'm going to write JRE, generic routing encapsulation. Right. So these are two types of encapsulation by which this can be formed. Right. So what will happen? This complete packet, this whole packet is going to be received by your foreign agent now, and foreign agent will see this that yeah, the source is home agent, that is okay, and there is a COA of MN 1118 is my network, and .2 is basically this mobile node. So this is basically my packet only. So let me forward this packet to the mobile node. But first of all, before forwarding it to the mobile node, it will decapsulate everything. Okay, so it will decapsulate it. It will remove this thing. It will remove this thing. Then it will forward to the mobile node. And then mobile node will gonna remove this packet, and it will see that who is the source and who is basically the receiver. And receiver is 117.10. It's a permanent IP address, and it will see that yeah, this packet is actually in my permanent IP permanent network. But now as I am in the foreign network, this has been received with the help of COA. So this is the generic routing encapsulation, and there are two types. Sorry, it's a simple encapsulation, and there are two types. One is minimal encapsulation, and another one is generic routing encapsulation. So I hope the simple meaning of encapsulation you got it right. Any doubt in uh, the specifications? If you have, please ask me. Okay. So now, once you understand the in a simple meaning of encapsulation, actually you need to remember. I mean, you need to mug up here a packet format of encapsulation. If I tell you the format here, let me just go to the download section, and there is file here. I actually have shared this file with you in the content section. If you see, there is encapsulation here. There's a definition of encapsulation and decapsulation. This IP and IP encapsulation is not in your course, so you do not need to remember. That will be okay. We have minimal encapsulation, this one, and this is a packet format. So this thing you need to remember. I mean, you can mug it up. I do not have any problem, but you need to mug this up. So what are the internal part here? You can see here that there is a version, there is a header length, There is a type of service, again the length, identification of your IP, different types of flag. No. Need to remember for MCQ. I think it is not going to be, these internal components are not going to be asked in your exam. But you need to remember that there are two encapsulation, minimal or encapsulation. Sorry, generic routing. So question could be formed like four types of encaps, four types of choices you have the in the question, like minimal, like generic routing, and then I will give like one wrong answer in there, right? So you need to choose that what is the wrong encapsulation there. You need to tick that like that. That kind of question will come in your MCQ, but not like in the packet format. You need to in इसमें से कुछ नहीं आएगा, okay? So do not worry about that. But if there is any theoretical exam like you need to write the answer, तब ऐसा पूछ सकते हैं, like that what I'm saying, okay? अगर आपका physical exam या book paper में अगर exam होता है, then if someone asks you that explain the encapsulation, then you need to write this whole thing. In your MCQ exam, nothing is going to be asked from the packet format. All right, so do not worry. इसमें से कुछ नहीं पूछा जाएगा. So, but if theoretical exam comes up, then you need to remember. Okay. Then there might be a question that what is the full form of GRE? So you need to remember that it is a generic routing encapsulation like that. So if you see that generic routing encapsulation, then it is nothing but a duplication of your minimal encapsulation. Just look this uh, packet here. This is a long packet, but uh, actually it is nothing but this packet only just had been you can see here, this is nothing but that packet itself. जो आपको याद करना है वो सिर्फ इतना है. I'm sorry, इतना part. This is a new part here. Otherwise, this has been copied from the earlier encapsulation. So this thing you need to remember if any question comes up. I understand that this it's a very long, lengthy packet format. Generally, do not students can learn it, but we generally give marks if you write the first header and the second header, and if you do not remember this one, we generally give marks here because we understand that no one can remember the whole length of packet, right? So this is one thing, minimal and generic routing encapsulation. Uh, After that, we have a scenario question here. It is known as a route optimization, sometimes also known as triangular routing. So what happens in the triangular routing problem? It looks something like this. So suppose that there are two people. One is coming from Japan. This is the Japani guy, and this is basically, let's say, the German guy. Two people are there, and they're coming from different states. So let's suppose that this is Japan here, and this is German here. Definitely, they have their own home agents. So this is home agent to handle that network, right? And currently, these two people are actually sitting in a room side by side in a complete different network. Let's suppose that this is Japan, this is Germany, and they are right now in Africa, or let's say Africa, and sitting side by side. Okay, and they have opened their computers, and this Japani guy, this guy, Japan, this is Germany. This Japani guy wants to communicate with this German guy. So now what will basically happen? As you can understand, it has been rightly been said that if Japanese send the packet to German, his computer will send the packet to the HA. You see here that this, when he sends the packet, so I will construct the packet. This packet not will not directly reflected over here. Okay, this packet will go to the HA home agent of German country here, and then Germany home agent will see that my mobile node is currently not in my location. It is actually in the Africa somewhere, and he get that idea, uh, and then it will redirect the packet with the help of encapsulation. Then it will forward it to the Africa foreign agent. So here we have a foreign agent. It will take that packet, it will decapsulate it. It will see that yes, this is actually my COA and the mobile node is currently in my network. Let me forward the actual packet. So it will decapsulate it, forward it to the this German guy, and then German guy will send back the replies to the Japanese guy. And this way, the whole packet is going to be flowed from one location to another location. So there is a problem actually. Even though they are sitting side by side nearby, and their computers are actually very near, but still the packet has to move to the country and deal with the home agent and then come back to the another country. So it takes a lot of time there, right? You're getting, so it is known as triangular routing problem. So it's something like this. So this is the Japanese guy, this is the home agent, and this is the mobile node, right? So this is the Japanese guy, this is German guy, and this is the home agent of German. So this is triangular routing problem. Now my question is, if there is one, if this is the HA home agent, how basically this knows that where my mobile node is currently situated? How this home agent knows about it? Anyone? Anyone who knows how this home agent knows that my mobile node is not right with me and I should encapsulate the packet and send it to the user, I mean mobile node. Current location from VLAB. What do we call this current location? Anyone? All right. So there is a name. If anyone remember, we actually talk a lot for this name. It is actually, it is rightly been said, it's care of address, right? So current location from VLA is good, but the name of that address is going to be COA, which is care of address. Please remember this. This question is going to come like 110%. All right. So this is a route optimization problem, and we can actually solve this problem by something called as binding update message. And how this works is basically uh, uh, we can send like binding updates, like when he form the packet, uh, this German agent, this foreign agent will basically send the binding update message whatsoever mobile node here in the network. Okay, so in the binding update message, what will happen, all the addresses of the home agent will be there. So the packet has not to route to the other network and come back to here, right? It can directly send the packets here and there because they are nearby, right? So this is another thing. It is, if you are interested, it is there here in the network. You can see this is actually the four additional messages that you need to send. This is actually a solution. Okay, binding request, binding update, acknowledgement, and warning. And this is actually the sequences of the packets moving in there. But it is not actually in your course, so do not worry. So this is your fourth chapter, and if you have any doubt in your fourth chapter, please let me know. Okay. Okay. Uh, then this is also going to be an important chapter, WAP, which is Wireless Application Protocol. And yeah, it is someone is working in the cabin. I think they will not come now. So yeah. Okay. I think now it is not coming, right? Okay. So we are dealing with a new chapter known as Wireless Application Protocol, WAP. And precisely this protocol, remember that this is a protocol and not any kind of software, hardware, application, or framework. This is a protocol. Remember, a question can be formed here that what exactly is WAP, right? So it works with various types of network. It could be used in GSM 800, which is your earlier network, GSM 1800, which is your new network, GSM 1900 is actually your new network as well. Works with 2G, 2.5, and 3G networks, right? So basically, it is used for handheld devices, which means your mobile, maybe for any PAM top, or maybe for tablets, maybe for any embedded devices, IoT. So we can use this app. Currently, it is not using that much because we have Android as a most suited mobile operating system and not this WAP. But still, some people are using WAP in their small devices. This has been used like in earlier days where we're using this one, Symbian phones, Nokia phones, and that time WAP was really very usable. Okay, so you can see here that it is a standard for application deployment over wireless device like PDAs and mobile phone. It is having a layered architecture, and this layered architecture is very similar to that of an OSI layer. If you remember OSI, it is going to be easy to understand WAP. So these are the layers. You can see here that there is a wireless application environment. Uh, there is a session protocol, wireless session protocol, uh, transaction protocol, transport layer security, and datagram protocol. And they are having a similarity, just like application environment is similar to that of application layer. Session protocol is similar to that of session layer. WTP is not being decided, but it's okay. Transport layer security deals with transport layer, and datagram protocol deals with network or yes, network layer, right? So if you yeah, so you need to refer this WAP architecture from the source. Still, if you cannot find the diagram, there is a PPT which I had shared in your e-content section. There I have the architecture, so you can take the diagram from there, no issue. So the first layer we understand is a wireless application environment, and they have different components in the uh, environment. So the first component is user agent. Generally, it is the user program. What user actually using for the interaction. So if you are having a client server architecture, then client is definitely using some kind of browser uh, to make a request to that server and get a reply from that server. So he's definitely using some kind of browser interface. In the similar way, if there is an e-commerce, sorry, something like, I mean, it just nothing but a kind of client program, an interface program, right? Next is a wireless markup language. It is a lightweight markup language, very similar to that of HTML language, having a uh, tag-based hierarchy. It is, you have seen this language to create like small pictures and OK and cancel buttons. Small interface has been created by this wireless markup language. Still, it has been used in your cameras, like your digital cameras, like this Canon and Sony and all. That cam shot, आपने देखा होगा कि उसके अंदर मेनू, कैंसल, ओके, ऐसे बटन्स होते हैं छोटे छोटे जो कि आप वेब के थ्रू बना सकते हैं. So this is the language. And according to that, according to the markup language, we have ML script as well, and very similar to that of JavaScript to give extra functionality to your HTML, sorry, WML. So we have WML script as well. The next one is a telephony application. See, this application environment gives you the interface actually by which you can interact with your service. So telephony application means your interface for phone, your interface for call controls, your interface for call setups. So all those interface that you had seen for dialing missed call and received call and recording and then dial pay, all these are coming in the wireless telephony application. After that, we have a push architecture, WAP push architecture. Well, basically, uh, push and pull architecture deals with your SMS, short messaging service. Uh, so basically, if you are requesting something from the server, then this architecture comes up, pull or push. Um, so in the WAE application environment, we have a logical model by which this application environment works. So what is this logical model? Well, this logical model consists of one side it is having a client, that means your user agent, and one side there is a server, and those servers are having services, different types of services. Um, so there could be a website written in WML, there could be small software written in WML. So that service, if you want to access, then there is a user agent for that. So in between client, I mean your user agent and the server, we have something called as gateway. So your diagram looks like this. So let me open. I think I do have. You see this if I have the PPT, a bundle of. Actually, I have here. Okay, so here you can see this is actually the architecture which I was talking about. Take this architecture. This PPT has been shared with you. Do not worry. So this is the logical model that I was talking about. This is your client, and these are your user agents. This is telephony application user agent, specifically meant for your call controls. This is basically a website or a web-related thing. This is other WAE agent. So what will happen basically? Between your client and server, we have a gateway, and this gateway is going to be an intermediary person, which will take your request and forward it to the intended server. And whatever the reply is coming from the intended server, it is going to be forwarded to the specific client who had requested earlier. This gateway has something called as encoders and decoders. And by the meaning of encoders and decoders, there might be a chance that this request, which this client is formatting, maybe it is very big request. So we need to compress it somehow, right? And this compression can be done with the help of encoders and decoders. And then it will be forwarded to the server, and then come back to the gateway. Gateway will decode things, and then it will forward it to the client agent. So things like that will happen in encoders and decoders, and it is important in early years because we have small mobiles and small space of memory, so we cannot formulate large or long request to the servers. We want very small request, and with the help of encoders we can do that. So you can see here that the gateway also will it also no encapsulation. Encapsulation is not going to be there in the WAP. WAP is not working like that. So encapsulation आपका दो जगह ही आता है. या तो अगर आपका इंटरनेट है तो आपका encapsulation करेगा. Otherwise, if you are using mobile IP for your mobile services, then encapsulation will be there. Encapsulation never work with WAP architecture. Okay, no encapsulation is there. Yeah, in encoding is something like I'll show you. See what will happen basically. You had seen this. Uh, no issue. See if I have like base 64 encode. You understand this thing. This is very important. It will come like every time in your network. So suppose that I'm writing like hello, how are you? I hope everything is fine. The problem is if you see each and every character here, they are taking some size, some space in the memory, right? And I understand that this the dot is actually taking the space, but I need to decompress this whole thing. I mean compress it whole thing, right? I should not use compression, but this is actually a word that I have in my mind right now. So it's like saving the space. So if I use this encode, where exactly it goes. Yeah, this you can see here that it is encoded in some numbers only, in numbers and capital letters and small letters. This is actually reduction the size. This will take a lot of size in the lot of space in the memory, but this will not take a lot of space in the memory, and that's why we are encoding here in between only. Okay, जब वो client side पे आएगा, again the same thing will come up. So we will not send this, but we will send this one. Okay, we will send this. So if you have now instead of encoding, we have here. If I use decode, then the same thing I had provided over here, and then if you do decoding, you will get the same thing. So they are not sending the whole characters, but instead they are sending the jumbled, or you can say the gibberish thing, so that no one can understand in between. So this is a reduction in the size. We call it as a translation sometimes. It is not actually compression. Compression is going to be a different topic, but just for the reduction of the request and response. You can see here to minimize the size of the data transfer over the air. So that's why we are doing it, right? And if you again see this thing, they have databases as well. You can see here that every server has storage capacity in the form of this databases. What other things they have? Content generators means actually nothing but so it is nothing but a kind of a database which stores the image, or which stores the multimedia, which stores the text, which stores some other things like maybe animations. So these are content generators, right? These databases. We are not calling databases here, we are calling content generators. So if a client is asking for some text information, then a specific content generator will give the text to the server. Server will send it to the gateway. Gateway will send it to the internet client. These are content generators. And you can see that standard encoding they are again using that we had discussed here, base 64 and UTF-8 and then so there might be a question comes up from here in the logical model that there might be a chance that they ask you about mm, Yeah, what is the work of the gateway? Okay, they could ask you what would be the work of gateway. From the WML, they can ask you that what exactly uh, what exactly is the tag in the WML. So they can formulate like this, like card and then maybe WML. Then might be some HTML tag they will give you. So that could be a wrong answer, right? So you need to tick that wrong answer. So So you can see that WML is a tag-based language, very similar to that of HTML, and it's a combination of deck and card. So, so this card is actually one screen, and this card is actually the second screen, so something like that. I do not have the complete program because there is nothing like programming in your mobile computing. Otherwise, there is a whole lot of programming in WML that you can do in Nokia Simulator. There is a software. If you are interested, you can download it from here. So, Nokia, there you can use this Nokia Simulator. I think yeah, tutorial point भी आपको देता है. Yes. Uh, मैंने ये देखो this type of thing you will see. See, it's a card actually. यहाँ पे भी है आपका ये कौन सा टूल है ये? It was actually earlier Nokia simulator only, but now I do not know. It's Nokia Web Toolkit. आप ये ले सकते हो यहाँ पर प्रोग्राम करोगे आप देखो WML है then card है then again card so it is just a combination of cards और जितने combination आप कार्ड के बनाओगे उसको हम deck बोलते हैं so like that this is copyright and there is an image as well so you can use that so you can use this Nokia Web Toolkit. I do not know people are not using now but if you are interested you can use it. Then other thing is other layer is a wireless telephony application, and this telephony application has a short abbreviation WTA and WTAI. And what exactly it gives you? It gives you several functions. So these are the functions that you can see. It gives you an interface for voice call control where you can set up your call, which means you can dial any number. Um, then we have a SMS functionality. We have a contact functionality. It means phone book where you can save the number, edit the number, and delete the number. We have a call logs. For that, we have another interface like dial, receive, and miss call. Right? This is a simple function of WTA. However, it is having a very lengthy specification. If you see the chapter, I have not given you that chapter, but yeah, actually, I need to give that. Okay, so now there is a push architecture, and what exactly this push architecture is, when you are interested in SMS, there are two types of SMS can be formed. One is push, and another one is pull. So when server gives you some response directly to your phone, uh, so you have not asked to the server to give some, but server is intended to give you some information implicitly, right? Then it is known as push architecture. It is always initiated by the server. So sometimes you had seen the messages coming from Geo, like the balance is exhausted, or maybe this is the new service, or this is the new scheme, like that. So those SMS are following the push architecture, okay? And when you are asking something from the server, it is actually following pull architecture. So maybe if you are dialing star 141 hash for Vodafone balance check, that is actually pull architecture. You are asking the server to give me the information. So that's the pull architecture. Okay, so your SMS is following two things: push and pull. Okay. This we had seen. Please refer the diagram. So your diagram is here only. The You can see here that here telephony and then push, and this is the diagram. So you can refer this diagram. It's a pull and push. Then we have WSP, which is a session protocol. And session means a dialogue control between you and your other partner or maybe server, to whosoever you are interacting with. So it will establish, sorry, I think this it establish a reliable session between you and your server. And the idea here is that when you are communicating with the other party, both parties should have the same level of protocol, or same level of services. So if I'm using 80 as a port number, then your other server or other client should also use port number 80 so that you can communicate with each other. So common level of protocol is necessary. Uh, Not only protocol, but the port numbers and other services. Then you should use encoding styles, that is okay. And then if you have started any session, then it should not be moved like infinity. It should terminate somewhere in the time. So it should suspend and resume the session. All right, so this is WSP. I hope you do not have any issue with that, right? If you have any, please tell me. Any doubt? Part 1,
Yes, sir, present.
6, 8, 9. Oh, sorry. 12,
Yes, yes, well.
okay, 17,
Yes, sir.
18, 19, 26, 33, 34, 30, 37, 30, 41, 45, 48, 49, 6, all right. 48, Umesh is here. I'm sorry. 49, hit 3, hit 3 is present. 5 is present. 60 is hit 3. 62, Mansi. 63, 66, 67, 69, 67, Nishant is not here. 72, Vikas. 73, 74, 76, 77, 79, 80, Ronak. 82, 85, 86, 87, 91, 100, 107, 108, 112, 113, 114, 119, 120, 121, 124, 126, 127, 129, 130, 134, 135, 136, 145, 164, I think. 119, I'm sorry, apologies. 05, Mehul, 145, all right, Sheena. 05 है Mehul, 010, Mohit Giri, okay, 16, and Haley is done. Anyone whose attendance is left?
Sir, 74.
Yeah, 74, all right. Malik, I'm so sorry, apologies. Anyone else? Okay, great. Okay, so wish you good luck. I think from fifth onwards, you are having your mid exam. So I wish you very good luck for that. And thank you so much, guys. I'll see you in the next session.